I've separated my beans into the different types, which is going to represent my different species in ecosystem 1. Now what I'm going to do is count up each organism for each different species. And I think I'm going to give each of my beans a particular species. So I gave each type of bean a specific species that it's going to represent. Now I'm going to count up each individual of the species. All right. So I counted 3 porcupines, 10 coyotes, 16 rabbits, 5 chipmunks, 28 deer, 14 opossums, 1 bobcat, 9 foxes, 5 robins, 12 wolves, 2 squirrels, 64 ants, and 6 owls in ecosystem 1. Now we have to do the same with ecosystem 2, making sure the same beans represent the same species. So for instance, all of the black beans in ecosystem 2 are still going to represent ants. So now I've separated my beans into the different species from my ecosystem 2 bag. Notice it's definitely different than ecosystem 1. So what I'm going to do is label the different species and count the number of individuals in each little pile. I've labeled my species for ecosystem 2. Notice that the same beans represent the same species as ecosystem 1. So I have little yellow beans for opossums in ecosystem 2 and little yellow beans for opossums in ecosystem 1. My rabbits are those green split peas in ecosystem 1, and over here my rabbits are the same exact thing, those little green split peas. So you just want to make sure that your beans, your species, are the same from ecosystem 1 to ecosystem 2. You have the same beans representing the same species. Alright, so I counted each individual for ecosystem 2. I have 3 robins, 7 ants, 9 coyotes, 54 wolves, 26 opossums, 12 foxes, 23 owls, 21 deer, 4 porcupines. Oh, forgot to count the rabbits. I have to count the rabbits. But you can see there's definitely differences between ecosystem 2 versus ecosystem 1. I think most notably we have a lot more ants and a lot less deer. So I wrote down all of my different species and their population sizes in my chart so that we can do some calculations. The first thing we want to do is add up the total amount of organisms in ecosystem 1. So all you have to do is add up all of the individuals for each of the populations. After calculating, I found that I had 175 beans in ecosystem 1, or 175 individual animals. Now we can find the relative abundance of each species by taking the number of each species and dividing it by the total number of organisms, and then timesing that number by 100. So for instance, to find the relative abundance of bobcats, we would do 1 divided by 175 times 100. I calculated that bobcats make up a total of 0.57% of ecosystem number 1. Now I'm going to find the relative abundance of each of my other species doing the same thing. I'm going to take 3, divide that by 175, and times it by 100. I've calculated the relative abundance for each of my species, and the next thing I'm going to do is calculate species richness, which is really easy because it's just the number of different species in the ecosystem. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 is going to be my species richness. All right, so we've got ecosystem 1 down. Now we have to do the same thing for ecosystem 2. And I did the same calculations for ecosystem number 2. Notice there's less species, so the species richness is 11, even though there's more individual organisms. In ecosystem 2, we had 202 beings, or 202 individual animals. Alright, so disaster struck, and a disease has spread across both of our ecosystems, and it's killed off 2/3 of the black bean population. So 2/3 of our ants have died off, and now we have to recalculate everything. So now I'm filling out the table for ecosystem 1 after our disease has spread. Notice that we still have a bobcat, 1 bobcat, we still have 3 porcupines, we still have 5 robins, we have 10 coyotes. So the species don't change, and the population size is not going to change except for the ants. We had 64 ants in ecosystem 1, but then 2/3 got killed, and we're left with 21 ants. So this is also going to change our total number of organisms in the ecosystem. We went from 175 to 132. So that means we have to recalculate the relative abundance of each species using the new total. Alright, so I've recalculated my relative abundances for ecosystem 1 using my new total number of organisms. And now we're going to have to do the same thing for ecosystem 2, where the disease also killed off 2/3 of the black bean population, or the ant population. So now I calculated my new relative abundances for ecosystem 2. So now I have my original calculations for ecosystem 1 and ecosystem 2. And I have my calculations after the disease killed off 2/3 of the black bean or ant population in ecosystem 1 and ecosystem 2. Now I've made my graph of the relative abundance of species in ecosystem 1 before and after disease. So my relative abundance is on my y-axis, and my species is on my x-axis. Now I put a key for my species up here because we have a ton of different species, so I use different colors for each species. And I graphed my relative abundance numbers from my first set of calculations and my second set of calculations for ecosystem 1. The BD stands for before disease. The AD stands for after disease. So this is just ecosystem 1. But we do have a lot going on. We have all the species, we have all the colors. Please note that this is relative abundance. It is not the number of species. It is the relative abundance that you calculated. So this is what your graph should look like for ecosystem 1 based on your data. It's not going to look exactly like this. And then we're gonna have to do a second graph for the relative abundance of species in ecosystem 2 before and after disease struck.